All right, got that recording going. Awesome. Good to see most of you back. That's good. You didn't get scared off Tuesday. I apologize. I was a little cranky. It's a 2 coffee kind of morning, and we'll have a little bit more fun today. I don't have to complain about people cheating, so it's much better. I don't have to talk about the syllabus. Just looking at our schedule, though, working through really quickly here some super basics in Python. Y'all have done some programming classes before. This won't be exciting, but it's the Python syntax that we want to start getting used to. Python is a little quirky your first time using it. C++, which I think almost all of you, I think one of you had Java and not C++, but they're the same too. It likes curly braces, and you put things. Is that a question? I'm sorry. Oh, okay. Sorry. Curly braces to organize things. So it's very syntax driven in I'm going to structure it in a certain way that the white space doesn't matter. As long as I have everything with curly braces and semicolons in a spot, I can put all my code on one line, and C++ didn't care. Now, everyone else cared because you would look horrible, but C++ didn't. Python does care. Python is very opinionated and cares the way that things are structured because it uses white space to signify things. So it's going to be a little awkward as we go to get started here. Let me go start up a new project. Or do I have the recent one? I'll just start a new one here. So we'll go new project. I'm going to make sure I put it in the correct repository, right? If you want to put anything else in your repository, I don't care. Feel free to put whatever you want in there. It's your repository. If you only want to put the labs and the projects in there, go for it. That's fine. Doesn't really matter. So PyCharm will remember the last folder you used. So if you want to have to flip back and forth, go for it. If you just all want to dump it in there, I'll ignore anything else. Feel free to put whatever you want in here. So I just need to make sure I pick the right folder. So I'm going to go find my 298. Oh, goodness. I have too many numbers in here now. 298. There it is. Winter 2025. Right. If I make my project in this folder, Git will be able to track it. Right? Git's entire job is to watch this folder and see if things change. That's all it does. It's a glorified file watcher. So we'll call this one, I don't know, week 1. Sure, we'll call it week 1. Takes just a minute to get going here. Again, it's not the fastest tool. It does a lot of really cool things. If you used Visual Studio before, you know our IDEs are not the fastest tools. It's okay. Grab your coffee, take a sip of coffee, enjoy your time. So this little starter code that it gives you, I threw away last time, I'm pretty sure. We got through this point. We would do a little hello world, right? We got through hello world? Okay, good. Hey, this is a sample Python script. You'll notice there's English in here, right, with pound signs. Now, I'm old and cranky enough that I still call this a pound sign. It's not a hashtag. And I believe it's only a hashtag when the words are attached to it, right? Otherwise, it's just a pound sign all by itself. If you put the pound sign and then some words, now that complete thing is your hashtag, including the words. So if you want to get pedantic and argue with people, because all engineers like to argue with people, because we all think we're right all the time, that's okay. We'll call it a pound sign. It's technically an octothorpe, if you like technical terms. That's a really fun word to throw out there sometimes too. But this is the code comment. We don't do // we do pound sign. I don't know why they wanted to be different, but sure. So pound sign is your comment. Leave a comment, put anything you want in here. It's perfectly fine. The school of thought that I was trained in and spent lots of years in is that comments are stupid. And they're mostly a waste of time, and we're not going to use them. Occasionally, there's some really good uses for comments. If you're building on a library and you want to document your API, please do that, because you're building your code for someone else to use. If you're writing code here and you're going to put a comment in, this is print hi function, accepts a name argument and prints the name. I could care less. This is not a helpful note here, because I can look at it, it says print hi, and it will print out hi. You've just wasted a bunch of time typing this. So from this point out, I will never ask you to write comments. I had a fun story when I was an undergrad. One of my first programming classes, we had to do, I don't even remember what we had to do. My code functioned perfectly, but I didn't get an A on it because I didn't include the comments that the prof asked for. I was like, my code works. Why am I getting marked down here? He's like, oh, you need comments, so I know that your code does what it's supposed to do. It's like, did you try hitting the run button? And he didn't appreciate my mouth. It's not a good idea to be sassy to your prof, at least when they're scoring you. So I won't ask for it. So I swore I would never ask people for comments as long as their code worked. And I've stuck to it. And depending on where you are in the industry, most people think comments are stupid. Aside from some particularly good specialty use cases. If you are leaving a comment that explains why you had to do a really weird looking thing, that's fantastic, because you're giving a little bit of additional context to what's happening. If you just leave a comment and say, this is print name, nobody cares, right? That's not a good use of your time here. Use a breakpoint in the code below to debug your script. This is just the starter template. It's trying to help you learn how to use PyCharm. Breakpoints and the debugger are your best friend. Right? Hopefully you spent lots of time doing that in your previous programming classes, so you can run your code line by line by line by line and see what variables are set. This is fantastic. We love the debugger. Just click your line number, you get your big fat red dot, and instead of the play button, right, you click the little bug button. Works out really nice. This if name is main is a little bit weird to Python. We'll get into that a little further as we go, but essentially the Python script that you run is known as main, and there's a bunch of these double underscore variables. There's special things that Python keeps track of, and whichever script you run is the main script. You can have lots of different Python scripts in a given program. The one that you click run on, they say, hey, I want to run this file here, I want to run this one, is the one that's going to run. So I can add other Python files in here. We'll call them modules in Python land to add other functionality. The one that you are importing from, or grabbing code from, is not main. So depending on what you want to do, you can throw stuff in here. But again, we don't really care about that one right now. So you'll see this def print main. We haven't got to functions yet. We'll get there. Is that next week we get to functions? Yeah, next week we'll get to functions. But this is a function. We're defining a function. The def keyword, I don't know why they didn't use define, but we use def. That's the name of the function. And you'll notice there's a colon here. So we don't use curly braces, we use a colon. And everything that belongs to print name, or print hi here, is going to be tabbed in. It looks like 4 spaces. It's configurable however you want to do here. But Python relies on the white space to say, hey, this belongs to this piece of code here. Right? It's attached to it. Once things start getting back to the regular alignment, we're no longer part of the function here. So we can define the function, and over here I can say print hello. And if I get a run, we never called the function, nothing happens. Right? We have hello. If I want, I can say, hey, I want to print hi. We'll put Eric in here. Right? That will call the function. I get my hi Eric here. Right? We called the function. Yeah, we'll get more into functions next week, but you'll notice the tabbed bit says it belongs here. And when we start looking at our conditionals, we'll be using all the indentation to show that this belongs here. Now, Python is lots of fun. I'll back that out for now. We can come back to functions a little bit here. With Python, it uses dynamic typing. So if you've come from Java or C++, you were strongly typed. You said, this is an integer, this is a float, this is a double, this is an instance of a particular class here. You had to tell the compiler what type it was. You may or may not have seen you can use the auto keyword, which would determine what type it was based on what you were giving it. So if you're familiar with auto, or var, I think it's var in Python, or Java, everything is like that in Python. So I say, hey, my number is 42. We're assigning the value 42 to the variable number. Python says, oh, this looks like an integer. Number must be an integer. Right? So then we can print number. We can print the type of number. So if you want to know what type Python thinks something is, you say type, and you give it the variable. Nope, I didn't want that. So 42 is the value here, and it's a type of integer. It's an integer, an instance of the integer class, int class here, which is kind of fun. We could say, I don't know, some number with decimal is, I don't know, 7.7. And again, we can print and figure out the type here. So we'll print some number with a decimal, and we'll print the type of some number with a decimal. And we'll see it's a type of float. So we don't have doubles, we just have floats. So there's ints, there's floats. And then we can deal with strings. You can say, hey, my name was Eric here, and I can print my name, and I can print the type of name. and we get, it is a str, short for string. These are strings here. Same thing, just a bunch of characters all strung together. These are some basic types that we work with. Now here's where it gets silly though. Because Python is dynamically typed, you can go and change it too. I can say number equals name. And then we'll go print number and print type here. And Python says, oh great, number's now Eric and a str. So you can change the type of value that's stored in a variable. Python could care less. So you're not fixed to the type that you assigned it when you created it. If we try to do this in C++ land, it'd be really confused and probably crash on us, right? I think that would probably even be a compile error. Can't assign to this type. Just doesn't work. You can do some weird things in Python and it will let you. I don't recommend you reuse your variables like this. That's just going to lead to a bad time. But you're welcome to do it if you want, right? Python will let you do some bad things because it's dynamically typed. One of the technical terms for it, which is kind of fun, is duck typing. They say if it looks like a duck and sounds like a duck, it must be a duck. We see what your variable looks like. Okay, it must be that type. Right? Python does that as it's running, which is lots of fun. So we've got, let me see what other variable types we had here. Py or E. I want to make sure I get all of his stuff here. Variables, floats, variables, names. Some of the keywords that you can't use, right? Oh goodness, that was really fast here. These are reserved words in Python. You can't name your variables these. Essentially, you can name your variable almost anything, right? And hopefully it's been drilled into you. You want good, nice, meaningful names. Depending on whose Python formatting you go with or style guideline you go with, the snake casing with underscores is most popular. I have seen some people who like the camel casing, like you usually do in C++, where you start with lowercase letters and every next word becomes capitalized. Most people in Python use the snake casing. I don't care what you use, but if you use terrible variable names like X and A and B and other things, I'll just make fun of you. You're not going to lose points, but it's just obnoxious, right? You want nicely named variable names because if you're anything like me, you're going to forget what it was the next day you look at it because you're going to spend a bunch of time coding and it makes a bunch of sense in the middle of it. Oh yeah, I called this thing STB because of course I know what that means. And then tomorrow you look at it, you're like, what is an STB? And you can't remember it all. So just use some long variable names. And all of you are efficiently lazy, right? You don't actually type this whole stuff out, right? You use your type ahead IntelliSense. So when I want some number, you just type a couple letters. It comes up here and you do tab to autocomplete, right? Please don't type everything, right? Most of the time we're using autocomplete here. So just because my variable name has 4 words in it now doesn't mean it's any harder to type than it would be, just num. Really, it's like one more keystroke. I just hit tab and it finishes out my sum number here with the decimal. Right? And you can arrow up and down if you want, and then tab to autocomplete. Right? We've been doing good variable names all along, I'm assuming. It's fantastic. Okay, good variable names are good. So don't use the reserved words in Python. We can't use any of those. Let's see. Arithmetic works the same way. Order of operations. By now, you know how order of operations work. You've passed a bunch of math classes here, right? If you want to force order of operations, use your parentheses, right? Everyone has those obnoxious. You're all not on Facebook because Facebook's for boomers now and millennials who got in on it too. They put those things around like, hey, everybody argues what 3 plus 3 divided by 3 times, what is it, 3 or something like this, or some bunch of nonsense. And they're like, oh, is this 1 or is this 9? And I blame math teachers for being lazy because when numbers touch, it's just an implied multiplication, right? And when order of operations happens, we go left to right. Just because they're touching doesn't mean we do this one first, right? You remember this one back from the first programming class? Okay, good. Order of operations works the same way. It's fantastic. Modulus, the same thing to get our remainder. Strings are fun. So Python lets us do some silly things with strings. So I can have, we'll say first name is Eric, and we'll say last name is Charneski. And again, you can use single quotes, you can use double quotes. As long as you start and end with the same one, Python doesn't care. Right? So I can say name equals first name plus last name. And then we'll print out name. And When you add strings together, you just concatenate them. You stick one onto the other here. So at this point, I don't have any spaces, right? Because I said literally just put Eric and Chernesky together. There's no spaces here. So if you want a space, right, I'll say, okay, I want to add a space character plus that one. And now I get some nice spaces between my first and last name, and it looks a little prettier here as we go. You can also throw things into print. I can say print first name. If you comma separate things with print, it will automatically space them for you. So I can say print first name, comma last name. And I'm going to get spaces in between the things here. And I can also say number here if I wanted. Oops, why did I change it? We'll do some number with a decimal. Some number with a decimal. That's a little bit more interesting. It'll just put them all together. Comma separate with print. Print is pretty friendly here. If you want to do funny things with print, you can change the ending character that print uses. So by default, it's going to go down a line here, but if I don't want it to go down a line and add a new line character, I can say, hey, change the ending character to be nothing. Just end with a quote instead of a new line character, and then I can print my last name, and then maybe I'll want to do the ending character as nothing again, and then maybe now I'll do some number with a decimal. So I get almost the same output, but if I'm changing my ending character, I don't get the spaces, right? Because I'm not comma separating. I'm doing one thing, saying end with nothing, one thing end with nothing. So I could add in a comma if I wanted, maybe a comma and a space to be a little prettier, or just the spaces. So you've got lots of flexibility. So you can use print to do a bunch of things depending on how you want your output to go here. Now, getting input from the user is really handy, really easy, pretty nice here. We don't even need to include or add any libraries. It's just built right in here. So I'll have something like favorite food. Favorite food is equal to, we're going to assign it the value of input, and then in parentheses, I can give it the prompt. So I can either print the prompt first, or I can just put it right here into input. What's your favorite food? And then later we'll print out favorite food. And how about it is great? I don't know. I'm assuming your favorite food is probably good. So in my console here, it just pauses. Right? It's just waiting for some info. What's your favorite food? Anybody? Hamburgers? Hamburger. Hamburger is great. Right? It gets me string input, which is really nice. So if I assign it to this, I'm going to get a string. If I say my favorite number is an input of what's your favorite number, and then we'll say, how about print your favorite number plus 10 is, and you can even do arithmetic right in here. We'll take favorite number plus 10. All right, favorite food, hamburger. What's your favorite number?
12.
12. Oh, shoot. We broke. You can only concatenate string, not int to string. Remember, when you get input, it's a string. Python doesn't care that it looks like an integer because it's storing it as a string right now. Anything that comes back from input is always going to be a string. So if you want it to be an integer, you have to force it to be an integer. We're going to cast it, say, hey, turn this whole thing into an int, please. So we're going to convert to int. I'll leave a comment every now and then if I remember it, and I try not to. Hopefully that's, if you want more of them, just shout at me. I'll add some more here. So hamburger, and then 12. Now we get your favorite number plus 10 is 22. Checks out, right? It can do the arithmetic. Is that a question? I'm sorry. Yeah.
So do you never need any semicolons at the end of statements in
Nope.
Python?
Nope. When Python sees a new line character, it's like, oh great, your line's done.
What was the portion that is sent and what I was taking that out, so I missed that.
So you can just, by default, print will add a new line character. If you don't want it to go down a new line, you can change the ending character to something other than new line. So in this case, you can have multiple prints and stay on the same line if you don't like to comma separate. Right? You can do those sorts of things. So we can do arithmetic right in here. Yeah.
Could you, I know that I'm pretty sure you can multiply strings by like an integer.
Yes, yep. Yeah, you can get, so what is it? NAN, I don't know what word is NAN, and then we're going to print word times 5, and then Batman. Hamburger, and 12. And now we get na Batman. So string times something is a string that many times. Lots of fun. Sure, Python's like, you want to multiply by 5? Okay, I'll give it to you 5 times. Because I don't know what else multiplying a string might mean to you. And we're not going to do any sort of weird matrix multiplication or, I don't know, nonsense stuff here. Yeah, so you can do some fun things with your inputs if you're not careful. If you wanted to do that, great. That's useful sometimes here. Other fun things we can do with print. So there's a formatted string you can use. So if you put an F first, and then we start a string here, this is going to be a formatted string, and we get take advantage of string interpolation. It's a fun technical term here, but essentially what that lets us do is not have to comma separate a bunch of things if I want to have a nice little string here. So I can say your favorite number is 10, or no, favorite number plus 10 is, and then in a set of curly braces, I don't know why, but curly braces, sure. Now we can have favorite number plus 10, and then maybe I just continue on my string here. I want to add an exclamation mark because that's fancy. So with a formatted string, Python says, okay, anything you put in curly braces, I'll go and jam into that string for you here. And you can do arithmetic, you can just put regular variables in, those sorts of things here. Hamburger, 12. And that's a little bit easier than having to comma separate and add a bunch of things if we're doing a bunch of stuff with strings, right? So like with first name and last name, it might be easier to say, I don't know, first name, colon, oops, you gotta have the F here, first name, and the curly brace, and then last name, sure. Right? So you can do any sort of just, I want to substitute in, interpolate, take this variable and jam it into the string here. And it's fun because it will convert things to strings for you when you're doing our arithmetic here. All right, so we got hamburgers, we got 12, right? Works out pretty nice. Get a nice looking output here. So for strings, getting some inputs, great. Comments we don't care about. Variables, sure. All right, awesome. So that's some good for variables. Again, super quick. I'm not expecting any of this to be groundbreaking here. You know how variables work here. Now for conditionals, if I want to do something, if else, right? So now maybe we'll say, how about we have, we've got your favorite number already, right? So we can say if your favorite number is less than 100, we're going to print your favorite number is small. And then notice when I hit enter, it stayed at this level of indentation. So the IDE is trying to be helpful and say, oh, do you probably want to add more stuff to that code block? Well, no, that was all I really wanted. So I backed out and it erased the tab for me. Now I can have my else here and say print, you have a big favorite number. Right? So if and else, if we give it our condition here, we don't need to set a parentheses. If you add it, Python doesn't care, because it's okay to have parentheses, right? But it's going to give us a little warning, right? These yellows are warnings. It says, hey, it's redundant. Do you want to remove redundant parentheses? Let me click on the light bulb and say, doesn't it give it to me? Yeah, remove. There we go. So whatever your condition is, and a colon. Anything after the colon, if it's indented, right, will belong to this. And then our else then is at the same level of indentation as the if. So it's going to say, okay, here's your if, run a bunch of stuff. I have other commands here, we'll say favorite number plus equals 10. Combined assignment operators work the same way here. Favorite number equals 22, and we can go change the entire value of it if we want, anything we wanted here, right? We just put in our block of code. Once it's no longer indented, we're out of the if block here. And if it's true, it runs, else it doesn't, right? Maybe let's go with less than 10 for a small number. And then if you wanted to have multiple else if clauses, the fine folks at Python said, well, it's too much work to type else space if, and they decided we type elif. I didn't come up with it. It drives me crazy, but sure. So you say elif, favorite number is less than 100. Print your favorite number has 2 digits. Right? Because it's not less than 10. So it's if it's less than 100, but it's not less than 10. It's probably between 10 and 100, right? It should be a 2-digit number, right? And then our else case, otherwise it's a really big favorite number. So you get elif all smushed together like. You can't do else if. Python gets upset with you. And now we saved, what is that, just 2 letters plus a space. We saved 3 keystrokes with an elif. But sure, we are much more efficient now this way. And it should run as we expect here. So favorite food, hamburger, 12. Our favorite number has 2 digits. 12, that works. Okay. Let's make sure hamburger, we'll just say 1. Our favorite number is small. Okay, right? Anytime you write code, you want to test it to make sure it works, right? Because any code worth writing is worth testing. But if you don't care if it works, don't write it. Right? It's pretty simple. So hopefully you run your code a lot and test things. You know, what if this goes in, this should come out. Right? We're going through that iterative process. Yeah.
Are you sure? So what if there's 2 things, like it's separated by an or?
Yeah, so we're going to get to adding more logical stuff in just a second. Yep. So if we wanted to check for other things here, so we've got favorite number. How about we do like the temperature and the weather maybe? So we'll ask for the temperature. So temperature, I'm going to say temp because honestly I can never remember if it's an E or a U. And sure, that's just embarrassing sometimes. So we'll do an input, probably an int, right? Most times people give you a temperature as a whole number, not like, hey, it's 22.5 degrees outside, right? You just look weird at people if they do that. So I think we're safe to use int here. So then we'll do an int of an input of what is the temperature, temp outside. And then how about we'll say weather is an input of what is the weather outside, like raining or snowing or sunny or something here, right? So we can say, hey, if the weather, now when we're comparing strings, we can just do an equals, double equal sign. If the weather equals snowing or snow, how about just snow, right? That's fine. If the weather is snow, then we might want to do something. Yeah.
Don't Chuck use a double quotation mark for the string?
No, either double or single. Python doesn't care.
So
Yep.
Python doesn't have char in it.
So single characters are still strings. Yep, so there's no char type, essentially. There technically is, but it's hard to get them. You have to try really hard to get them. I'm sorry? I'm sorry, I can't.
Isn't it like Unicode or something?
So a single character is stored as the Unicode value, and we can convert between the Unicode value and back to the character value individually. Yeah, we can look at that in just a minute. Here, I'll put them down here so I don't forget. So it's chur and ord. All right, so if the weather is equal to snow, right, and then how about and the temp is less than 32, right? So when you're anding things together, we don't have to do ampersand, ampersand. We just use the word and. Because the fine folks at Python are like, that's silly. Let's do it in English. We're writing the compiler, the interpreter, right? You don't have to use silly characters. We can use the word and. So you get an and here. So if it's snow and it's less than 22, we'll print out, bring your snow pants. I don't know. Sure. Elif. The weather is sunny, equal to sunny, and the temp is less than 32. Let's print, I don't know, wear pants. Right? As long as you're not wearing shorts, you're probably fine if it's sunny out and cold. And then maybe else something here. Right? Maybe we'll just print, this is a weird winter. I don't know. So if we get snow and temp, less than 32, it should say snow pants. If we get sunny and temp less than 22, we get pants. Otherwise, this is some weird weather for winter, right? Usually it's kind of cold in the winter time around here. So you can combine them with ands. Ands and ors work the same way. If you wanted an or, right, maybe we'll do one more. If the weather is hot or temp is greater than 32. How about that? Right? You can be if we've said hot in text here, or the temperature was more than 32, we're good to go here. And then we have else print. I don't know. Right. And you can just chain as many of these together as you want. There's no real limit here to how many you want to type in here. Remember with ors, if either one is true, the whole thing is true. With ands, both have to be true to make the whole thing true. Works the same way. All right. For character, so if you want something as a single character, you can use the char of it here. So char will give you the single character here. It's not super useful all the time, depending on what you want to do here. We can do some silly things with it. So how about we do like your initial? Initial is an input of enter your first initial, And then we want the char of the initial, print. No, that wants, so character wants integers. So we have to get the first letter only. It's kind of obnoxious. We're getting a little ahead of ourselves. So if you want just the first letter here, you can go to your initial and it will say, I want index 0 of that with our square braces. We'll get to this in a little while here. That'll get us the first letter of whatever they typed in here. With that, I can get the ordinal value of that letter if I wanted, which is the Unicode value of that letter, essentially. So this is, we'll say, the formatted string, Unicode value of your initial. We'll get the ordinal value of that. And then if you wanted to do silly things, we could do some arithmetic with this now. So your initial, I don't know, what, +1 is all of that, the ordinal value, +1, converted back to a character, char here. So we can shift the letter down 1 in the alphabet, right? So if it goes from E, it should go to F. So let's go hamburger, 1, 32, snow. Oh yeah, it didn't hit any of those. First initial E, ordinal value, Unicode value, 69. Right, we start with 65 for capital A. I don't know why that's in my head. It should not be in your head. We don't care what Unicode values of numbers are, but sure, 65 is a capital A. +1 turns into an F, right? We just shift it down 1. So if you wanted to take all of your name and shift it one letter at a time, we could do that. We haven't really got to iterations and loops yet. But that's the sort of fun thing we could do with, once we go through loops, right, iterations, we can loop through every character in your name and do something with it here. Lots of fun stuff there if you wanted. Yeah.
That input function, can you do the same thing as you did with print by changing like the end character?
So inside of here, not as easily. So input really only expects you to give it the prompt.
Okay.
There's not a lot of opportunities to change. So if you want more of a custom prompt, you would print, and then you could use input that's like empty. It doesn't have to have a prompt, right? But so that's an option if you want to do something a little bit more custom with that.
What does the F do in the print function?
So this gives you the formatted string, so you can do the curly braces to get string interpolation. So instead of having to comma separate everything and then assume it gets smushed together the right way, I can just throw it right into my prints here. And really this is for any string. You don't have to be printing the string. We can do a lot of things with strings and string interpolation. It's easy for us to see the output when we print it all the time. Yep. So when we start writing classes and we have string representations of instances of classes, formatted strings are super helpful. So I can like return a given value with those. Works out really nice. All right, so we got through that one here. Let's see, for conditionals. So it gives you back the type of Boolean. So there is a type for bool. So this is, I don't know, is true. We'll say capital T true. Now Python is case sensitive. I probably should have said that here too. So if you're expecting snow in lowercase and someone types snow in uppercase, it's not going to match, right? Because it compares, does the first letter match the first letter? Does the second letter match the second letter? Does the third letter match the third letter? Case by case, right? A capital A is different than a lowercase a, right? Because 65 is different than, I don't know, whatever that number is. And it's more than 26 because they added other things here. I don't understand. I don't know. I didn't come up with Unicode, so I guess I can't complain too much. But is true, right? Is capital T true? Lowercase t true? Python doesn't know what you're talking about. And now it gets upset with you. It says unresolved reference true. I don't know what this variable is, right? So capital T true, true here. So we can say, hey, I want to print the type of true, or is true here. And we'll get, this is the bool type. So let me just run just this little bit here. Where is it? Execute selection. Here we go. I don't have to run the whole program every time. I keep forgetting. It's a class bool. It's a boolean, right? It's true or false. So you can have those, right? All of our conditions evaluate to a bool, to a true or false. Python is a little bit fun too. I can say, hey, if favorite number, print the favorite number isn't 0. Else print that's a weird favorite number. I've never met anybody who ever told me their favorite number was 0. Maybe a math teacher might, because math profs are just weird. and some of them might like 0. But you'd think this would be awkward, right, and confusing, and Python might not know what to do with it. No, Python's happy. Python is more than happy with that. So 12 is our favorite number. What do we want? Like 20, snow, sure. We have to wear snow pants, initial E. And it says my favorite number isn't 0. So Python is truthy. That's a funny word here. But any variable can be evaluated to true or false. Literally anything. It's crazy most of the time. And it's not always helpful because you could type something by mistake and like, oh, maybe I forgot to add the equals 42 or whatever we wanted here, right? I can just type a favorite number and continue on. And Python's like, oh, great. You want to know if favorite number is true or not. So anything other than 0 is true. 0 is false. It sort of boils back down to like, you've got the 0 and 1 as a Boolean. It's either on or it's off. 0 is false. 1 is true. So anything other than 0 is going to be true. For strings, anything other than an empty string is going to be true. So I could have, name is empty to start, and then I can say if name, print nice name, else print forgot to ask for the name. Right? If we just run that bit here, we forgot to ask for their name. Right? Maybe you liked the habit and style, and depending on who you had for 150 or 200, they might have beaten you to death if you didn't declare all of your variable names at the very start of your program, because that is the one and only good style. Sure, whatever, I don't care. You can declare variable names anywhere you want. We don't care. It makes you look a little smarter if you put them all up at the top, because you look prepared. Sure, go for it. But you can declare it and never go assign it a value, right? Other than blank here. So you got to be a little careful, but empty strings are false. If there's a value in your string, it's true. If it has any sort of value at all, it's going to be true. So it's fun in conditional sometimes. We also have the not operator. Instead of the exclamation point, you just say not. Right? Save some time there as well. If, else if, yep. Else if. You can nest the same way we can in other languages. So if, those ones are silly here. How about back up here? We'll go if snow, we'll try and rewrite this here. So we can say, hey, if the weather is equal to snow, and then if the temp is less than 32, print snow pants. If it's more than 32 and it's snowing, we'll print that will melt soon. I don't know, right? You can nest ifs inside of ifs. Nothing super new here. You'll just get further and further and further and further in, just like you did before. At some point, you're too far indented, and it just looks really ugly, right? And you want to reconsider your life choices and why you have 7 different nested if statements here, because that's just going to be weird, right? But you can, right? Python lets you do it. Nested ifs. You know how we crashed earlier, right? When I tried doing some different types here. Let's see. So let's go when I was doing arithmetic. Favorite food was hamburger. And if I said, what's your favorite number? And I said 10, T-E-N. Now it crashes here with a value error. Invalid literal for int with base 10, 10. So I gave it 10 as a string. It was expecting to convert it to an int, and Python's not quite that smart yet. It's not going to do that conversion for me. So we get this value error. So if you want to avoid that, you can use the try block. So you can say, I want to try something. If an exception happens, here's what we do. Right? It's exceptions. You probably did that in 200, right? So we do the same thing with a try block. Right? So we try and we accept. Right? Works pretty much the same way for us here. And you can catch exceptions if you want. Right? And you can handle them. You can do specific types. Well, I think we get more into that. And isn't there a whole chapter for that? Oh, there's not. Okay, so there's not a whole chapter for exceptions. But you can catch specific types if you want to go nuts with it here. Yeah. The short circuiting works the same way. I don't know if you spend a whole lot of time on this. We usually don't spend too much time on it. But if the first thing is false, you never get to the next thing with an AND, because it realizes it's a big waste of time to compute the next thing if it's going to be false anyway. And the opposite with ORs, if the first thing is true, it never looks at the next thing because you ORed it together. Okay. I think a couple of you shook your head. That sounded familiar. It's probably one of the things you heard about and forgot because nobody cares. That's okay. And debugging, great. Hey, look at that. We got through the chapters. Again, really quick intro. go read the chapter, right? You watched me do it once, you can read the chapter, you'll practice it. You got to do things a couple times to get it stuck in your memory. You know how memory works, right? You figure out learning by now. It's a very active individual sport. You got to participate, and you got to try and do a couple things. All right, so we talked a little bit about GitHub. I showed you a quick demo. We got through most of it before we ran out of time on Tuesday, right? So most of you, I didn't actually count because there's a lot of you here, sent me an invite to join your repository. Fantastic, thank you. For the official assignment where you're going to turn something in and get points in Canvas. Oh, everyone's excited, it's had points. Look at that. I'm also going to need you to add the grader for the course, but I don't have their GitHub username yet. I'm meeting them this afternoon. We got a great grad student who's going to be a grader and help grade all the things, because at some point the college decided that it's too much work for the prof to grade things, or lecturer to grade things. Sorry, I can't call myself a professor. That they'll let me have a grader, but the grader's not allowed to use any knowledge at all. They have to pretend like they're stupid, because otherwise the graduate employees union says they're doing graduate work and they should be paid better than a grader gets paid, which is crap pay. Sure, all sorts of things here. So they'll be completely objective for the assignments. I'll say, hey, go test this input, this should come out. And I could technically tell anybody how to do that. Somebody who's a master's student in computer science should be able to go download your code out of GitHub and run it without me giving them a lot of directions, but sure, they can do that. So they'll test it all. If it works, great, you'll get points. If it doesn't work, they have to kick it back to me to be subjective and say, oh, maybe you get some partial points here and there, because they're not allowed to use any professional judgment. You can tell I'm a little irritated by it. I told you I wouldn't be too cranky today, I'm sorry. It's like, I get it. The GEO is looking out for people, making sure we don't abuse grad students, making them be TAs, but pay them like a grader. So I can appreciate that. So I'll post it in Canvas, and one of the other steps you have to do is also add them so they have access to your code. Okay, you've added me, great. That's really the most important one, but they're also going to be helping grade things, so you'll have to add access for them so they can go in and grade your stuff and look at it here. So for our assignment, yeah.
We sent an announcement of his username.
Yeah. So I'll put it in the Canvas assignment as well, in there. So going through the workflow again, I want to show you. Right, you made the repository. You can keep the exact same one for every assignment. Perfectly fine. Just make a new project, right, and it gets organized that way. So if I go to my GitHub here, and I take a look at my repository 298 here, it should say, hey, there's a bunch of new stuff here. Right, week 1 was the name of the project. It made a folder. Love folders, right? We like to organize things. All this other stuff in the .idea folder, just let it happen, right? That's all the PyCharm magic happening behind the scenes. We love it. I really care about the main PY file. Having everything else there makes it easy for me. If I really wanted to go and download your code and run it, or clone your repository and run your code, I can one-click open it in PyCharm and not have to do a bunch of other work here. So, yeah.
Can't you also, I think PyCharm also built in GitHub.
Yes, yeah, PyCharm can do it. So I like the GitHub desktop because it's simple, and I use it for every language that I teach. So I don't have to show, this is how you do it in Visual Studio, this is how you do it in VS Code, this is how you do it in RStudio, this is how you do it in all these other places here. So I like this one. If you can make the other one work, more power to you. Right?
I kind of did.
Yeah, that's great.
It's probably better than having 2 applications.
Sure. Yeah, whichever way you like. No worries. So we're just going to make sure we commit, right? You have to give it a commit summary. That's the required box. I could care less what you put here. You probably don't want to swear at me, but some people like to swear at their computer. Like, why isn't this freaking code working here? And they leave a bunch of commits, and it's funny sometimes. Do whatever you want. When you go out and work in industry, they'll tell you what to put there, and you just smile and nod and put what they tell you to put in these boxes, and everyone's happy here. So we'll call this week 1. We commit. So now my local copy of the repository has everything committed and saved. I haven't pushed to the cloud yet, so the central repository, the cloud, GitHub, doesn't know about it yet. You got to make sure you do the next step, because if you can't see it on GitHub, I can't see it on GitHub. And if I can't see it on GitHub, I can't score it, or our grader can't score it either. So I'm going to push to go sync with the cloud. Now that I've pushed, I can say view on GitHub, and says, oh, here's your nice little web interface here. I can go look at week 1 here. Here's the main PY file. This URL is what you're going to turn into Canvas. Right? Here's where my code is, Eric. Make it nice and easy for us to find. Right? If we have to go poke around and find your file, it starts to get irritating. Right? And you don't want people to be irritated when they're grading your stuff. Right? So here's your file. You can give that link in here. The other thing we're going to do, so our projects are going to get bigger. So your first Hello World one, fine, super easy. You don't have to do a whole lot here. You're going to introduce yourself. I'll tell you in a minute. I want to know like 5 things about you. That's all. It'll go real fast. The other thing we can do, which is really fun, because GitHub is made for code collaboration and it's a very common platform, it has this built-in support for README files. README files are fantastic. So ours are really boring here. You can put anything you want in there. You don't have to have a whole lot. But some GitHubs have really cool READMEs, like here's Microsoft's VS Code. Their README file has all sorts of cool information about VS Code. VS Code's an open source tool they support here, and it tells you all sorts of fun things here. It has a bunch of links to things. It has screenshots. You can do really cool stuff in the README file, right? What I would like you to do, if you do it for the first project, great. If you don't, I don't care that much because it's just it's like 5 lines of code. But what we're going to do is take a screenshot of your program running and add it to a README file. So to do that, I'm going to come to week 1. Any way you want to, we're going to add a README file. I like to do it right from PyCharm because I'm lazy. I don't like to go to other places. You can do it right in Explorer. You can do it in your Finder tool, whatever. We're going to go add a new file. I'm going to call it readme.md. Readme.md, this is a markdown file. So we're going to readme.md. Again, because PyCharm knows Git exists, it tries to do a bunch of things in Git for you automatically here. I always say cancel. I don't care. You can say add. It really doesn't hurt anything here, one way or the other. In the README file, we can go and add a bunch of stuff, right? I don't need to add anything right now because what I'm going to do is add a screenshot. So just having the file here is great. I'm going to go run our program again here. This is probably enough. Once you get the output of your program, we're going to take a little screenshot of it here. You can use your print screen key. I think the screen snip tool in Windows, that's the Windows key, Shift S. There's a command in Mac that does a little screen snipping thing here. This just makes it a little bit cleaner. You just drag and drop over what you want, or drag over what you want. It puts it in the clipboard. I'm going to go commit here the README file. So here's README, and I'll commit and push. Back out on the website then, when I go into my week 1 folder, there's a README file here. I can click the README file, and I get a browser editor. I don't recommend you do this for code. Technically, you could do this for code. You can edit your code files right in the browser. Not a great place to write code, I promise. It works, but it's not a great place here. But the README file, I just hit Control-V for paste. It pastes in from my clipboard, automatically uploads the image somewhere on GitHub, github.com, user attachments, and some GUID here, sure. And we'll link it with Markdown code for me here. I can say commit and commit. And now my README file has a nice little screenshot built right in. So if I give you this link here of here's the project folder, it's got my Python code, and it's got a README file, I can quickly see the output that, hey, your code ran and did something here, right? Just having the output saves a little bit of time here, right? And again, I'll be honest, most of the time I can look at your code and know if it works or not, right? At this level, we're not doing anything crazy complex. If I'm not sure if it works, that's when I actually go run someone's code, right? But after 20 years, you can look at most easy looking code and figure out if it works or not. Yeah?
So for the projects, you want us to create a README file inside of the specific project, not inside of the whole repository?
Yeah, so because we're going to have multiple projects in the same repository, if you put it in the first level README, you're going to have a bunch of junk in here, and it'll have like, here's my project 0 README, here's the project, like, it's just a little bit more cluttered. Putting it inside of the folder kind of organizes it a little bit nicer here, just makes it a little bit easier to do that here. All we have to do is go add the README file ourselves, and you can go edit it right in the browser. And if you want to go edit your Python code in the browser, you're welcome to do it here. I've changed my favorite number to 10 or something, commit it here. Sure, you can give it a message. That gets awkward, but you can if you really want to here. Now on GitHub, because I've changed something from GitHub that my local repository doesn't know about, when I click fetch, it's going to say, oh, hey, you need to pull. Right? Git is a push and pull system. You push your changes out and you pull changes down. Something changed that my local repository does it, so I'm going to go ahead and pull, and then I'll go get that change locally here. And if I go back, I can open up my README file, and it says, oh, hey, here's the image link. It even gives me a nice little preview of it. Like, PyCharm knows that README files do stuff here, which is fantastic. Getting the image onto GitHub is awkward, and that's why I like using the browser to just copy paste here. You can technically upload images and link images. It's just a small pain to do it that way, and I'm lazy. I like to do what I think is the easiest way to do it. So adding the README, going to the website, and pasting my screenshot works a little faster. And you can paste in 5 different screenshots. You know, depending on how much output you have, you can cut it into a bunch of different sections here, however you wanted to do that. Does that sound reasonable? All right, cool. So let's talk about the assignment then. Let's go our first assignment. I'm going to call it a project because I don't have another good grouping for it here. It's like worth going to be 5 points. All the other projects will be worth a whole lot more. But this is our very first practice. This one will be due next week. I need to make sure that GitHub works before you start doing actual projects using it here. So this is sort of our trial run. If it doesn't work the first time, we're going to tell you it didn't work, try again. Right? Everybody should get the 5 points here. Right? That's the goal. I want to make sure that you can use the GitHub workflow here. Now, I do want to point out here, just because some people really like this here, they click this little plus button and they upload files. Please, 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 please do not do this. This irritates me to no end. Use the GitHub workflow. Okay? Uploading files one at a time takes way more time and energy. I know it sounds like it's going to be much faster for you, but learning how Git works and using Git and using GitHub to make commits and to push your commits will save you so much time in the future. Right? All of your classes that you write code for, you should probably make your own private repository for, because getting it out into the cloud means that if your laptop breaks, the cloud still has a copy. Right? You don't need to go find stuff out of the OneDrive. Sure, you can use your OneDrive or Google Docs or whatever you want here, but right? I can't guarantee it, but basically you'll go use Git when you go out and get a job in the industry. Right? Is it source control tools? Industry. Let's see. 10 best. Oh, I want like the percentage here. Percentage of. Is this it? I don't know. There's probably going to be a good link here, right? It was like 85% or something was more. Yep, here we go. Sure, we accept their cookies. Here we go. Source control collaboration tools like GitHub, GitLab, Bitbucket, those are all Git-based ones here. 85-ish%, right? Looks like that for tools being used. Almost everyone's going to do it. Maybe a couple of you poor folks won't have nice tools because your company sucks. And you should go say, hey, we should spend some money on a good tool. At some point, you want to advocate for that. Maybe not your first day, but anyway, so getting used to using it will be good. Please don't use file upload, right? It does technically work. It's just, don't do it, right? It's not worth it. It's not worth it. All right, so we'll go to our assignments. We'll go to Project 0. So next week, before class starts, ideally, if you run, no, does it not save? Come on, 9:30 a.m. There we go. All right, 5 points. All right, if you run into issues, it's okay. I can help you Thursday. If something didn't work out well, let me know. I've got lots of time after class before my next class starts because I don't have class till 2. So I'll wander over to the CIS building where no one ever goes anyway. And it's nice when people stop by because otherwise it's lonely. But I'll help you with that if you've got questions. So we're going to create a GitHub repository and add Eric and say collaborator. Again, I'll get their GitHub username in a second. I'm meeting with them right after this class here, so I'll have it shortly for you. And you can do all the stuff first and then go add them whenever I get their name and send it to you here. GitHub repository, and this is what, make sure to add a README and use the Python git ignore template. Wait, do you want screenshots of that? Is that helpful? Oh, that's the wrong one here. Come on. There we go. Repositories. Make a private GitHub repository. A new repository, right? CIS 298 or something here. You make it private. Add the README. Do your Python git ignore. Okay. Like that? Is that helpful? Okay. I can drop that in. Wow, that was fun. I don't know what that big line was here. Come on, Canvas, work. Where's my resize? Okay. Usually I get like a left and right too, that's fine. All right. So then for collaborators, right, once you have your repository, you go to settings, collaborators, log in. And you go add people. Again, I can't add myself because it doesn't recognize my own username here, but you'd go to this spot here, settings, collaborators, add Eric. Click settings. All right, you got that. And then we're going to create we're going to clone the project. So clone the repository to your computer. So if you like the GitHub desktop tool, right, you go with the green code button, you say open with GitHub desktop. If you like other ways, go for it. I don't care which way you get it here, but this one will open the GitHub desktop tool, launch the repository, say, hey, I'm going to clone it for you. You can put it anywhere you want. If you don't remember where it went, say show in Explorer. Here's my path. When I go to PyCharm to start my project, that's where I'm going to put it. All right, so make a new project in that repository folder. All right, maybe we'll call this project 0. Right. This is going to be, where's my snip tool? I wanted the snip tool for a second. Really? All right, hang on. It's being cranky. Rectangle, new snip. There we go. I just want to highlight this one for you here. So this is your folder here, right? Make sure that's whatever your folder name is. Create a PyCharm project in that folder, right? Again, your folder name might vary. It doesn't have to be named the same. It's helpful if it is, because then I know which one it is, because I've got 20, 30, 40, 100 of you this semester making GitHub. Oh, actually, no. Like 200 people making GitHub repositories. But sure, I can figure it out because you attach it in Canvas. Right? You'll put it in Canvas here. So in your project. Ooh, you know, we should actually do this in pairs because it's good to know a friend. Right? It is good to know a friend here. So in our project, we're going to write some Python code that introduces a friend in class. So partner up with somebody, and you're going to ask them a couple questions. A couple questions, and print the answers in Python. And not very interesting here, but this way you get to know somebody. If you miss class, pester them, be like, hey, what did I miss? Get the cliff notes real quick, watch the recording. Ideally, you watch the recording. I can't make people do that, that sort of thing. And collaborate. You are welcome to talk in English with your partner. With the whole class, if you really want to start a group chat with 60 people. That sounds awful, having 60 people in a group chat, but go for it. Talk in English all you want about the projects. Right? The point that you're working on your own is translating pseudocode into Python. Right? That's the whole thing we're practicing, is how do I write Python code? You can probably already solve all these problems in C++. Right? The goal of this class is how do we solve these problems in Python? Right? So sure, talk about it in English all you want. Here, use my Discord server if you want. You can post stuff in the class channel there. You can start your own private one so I don't see your chat if you so care to. Again, I don't particularly care that much. But don't share Python code. Right? Make sure people are at least putting in a little bit of effort here to learn their own stuff. That fair? Okay, so we'll ask them a couple questions. So their name and major. What do they do when they aren't here? That's like job, hobbies, other, I don't know, whatever else things you have here. A fun fact about them, and what is the coolest thing they have seen technology do. Right? Just a couple questions, not a whole lot, just helps me get to know you, make sure we get this Git process working, that PyCharm got installed, you can actually run Python code. Believe it or not, I had someone one time, like halfway into class, tell me that they couldn't actually write code or run code. They're like, oh, my editor hasn't been working. And it was like 7 weeks into class. I'm like, why are you telling me this now? Like their first 2 projects just sucked. And they're like, oh yeah, because I was doing it in Notepad or something. It's like, what is wrong with you? I didn't say that. That probably sounds mean. I might have actually said that. I have no filter. But that sort of thing. All right, so again, real fast, right? Make your project. I'll call it project 0. I'll do it in a new window. And then we're going to add a README file to the project, run the code, grab a screenshot of the output, add README, commit and push to GitHub, grab a screenshot of the output, go edit the project README file, file to paste the screenshot, and submit the URL of the project folder. Right? So what you're going to turn in is a website URL. That's all you have to get. Yeah.
Can you show like how to add the BB file to the project?
Yeah, so I'll do it here. So project 0, I'll go add mine here real quick. So I'll introduce myself, because why not here? I don't have a partner. We'll print Eric Chernesky, doctoral dropout. At some point, I might like to go back, but wasn't able to finish in time. And my advisor, thankfully, was like, by the time I was able to make it back from family medical leave, he's like, you got a year left, you will not finish a dissertation. Don't try. I was like, I got it. Not going to happen. He could have just taken my tuition dollars and like kept being my advisor for a year while I struggled at this thing. And he's like, no, don't do it, which was pretty cool. So what do I do when I'm not here? I like to play D&D. I like to run. I like to read. I've got a stack of unread books, but still eventually we'll read them. That stack keeps growing bigger and bigger as I find new books here, but that's fun. I teach at OCC and Walsh as well, and play with my kids. That sounds really weird. I'm going to say my kids. And 7. I have 7 kids at home right now, plus 2 bonus ones. So it's a little crazy at home. Right? And then a fun fact about me is Eric likes to run marathons. And, maybe run is the wrong word here. Run, walk. As long as I make the distance, I'm happy. I've yet to run the entire 26.2 miles because I just don't put enough time into training. But there's a really cool Free Press International Marathon. You start in Detroit, you run into Canada, over the Ambassador Bridge, back through the tunnel. They call it the Underwater Mile. It's kind of fun. It's not exactly a mile, but that's okay. Everyone rounds. And then back, and you run through Indian Village, and people give out shots of Fireball in Indian Village while you're running a marathon, which is a terrible idea to do, but it's hilarious and fun, so you do it anyway. And they give out beer and things. It's a good time. But it's fun, so I like to do that. And then print, the coolest thing I've seen technology do is probably related to healthcare. Again, I came from a healthcare analytics company. We were focused more on population health and doing large analytic style things, but I'm most excited about the individualized personal healthcare sort of stuff where you can get a second or third opinion. AI can be a tool that your doctor uses to help them not miss things, to give them another look at sort of things here. So like personalized healthcare. Now, I don't recommend you let AI be your primary doctor. I do think it will help primary care doctors and specialists be better, right? Because AI is not going to forget your entire medical history, right? It can grab your medical history, analyze it, figure everything out about it, and they're not going to forget, oh, by the way, your mother's mother had heart disease. That might be a contributing factor to what's happening to you. That sort of stuff here, where your primary care doc has tons and tons of patients because they have to make money. Primary care docs get paid the least out of all doctors, which is crazy because they're like the most important kind of doctor to keep us all healthy, and out of hospitals, which are more expensive. That sort of stuff with AI. And then the cool stuff they're doing with imaging as well. We can get AI image recognition, like stuff scanning your skin, look for precancer, things like that, so we can catch skin cancer earlier, which gives you a better outcome. That sort of stuff is really cool. I don't know, lots of fun stuff. That's what I think is the coolest. And Beat Saber. Like VR Beat Saber is for some reason like the coolest thing. I don't know why. And it's ridiculous, but it's just a lot of fun. All right, so that's me. So to add the README file, then you right-click your project, you want a new file, and say, I want to add readme.md. Now we got a markdown file. Now when I go commit it here, it says, hey, I've got a main file and a README file, right? Give it a summary like project 0, commit and push, we get it out to the cloud. Again, we go run our program, grab the screenshot, Windows Shift S if you like keyboard shortcuts here, and then we'll go back. You can say view on GitHub, go to your project 0 folder, click your README file, click the little pencil here. I know it's like 15 steps, but you'll do it after every single time. Eventually it won't feel so bad, and you won't want to touch the file upload option, I promise. Here, you give a little paste, commit and commit. Go back to your project 0 folder. You've got your code file here I can link to. You've got the README file, which shows me what's in it right now. You can add other stuff to it as well if you want here, but that's fine. Grab this URL, go over to Canvas. That's what you're going to turn in. So all I need to do is get you the GitHub username for our grader. Again, I'm meeting with them after class at some point before my next class. I'll plug that in. I'll send an announcement as well, so you have that. I think you've already added me for most of you. If you haven't yet, go ahead and do that. But that, and then maybe read the textbook. It's really slow to start, but that's okay. Just getting us through. We'll get into some more interesting stuff once we jump into functions. You can do some weird things with functions in Python, and it's a lot of fun, which will be cool. And iterations, loops, we love loops, going through those sorts of things. And I think that's it. Questions, thoughts, concerns? All right, yes?
Do you care if we don't use PyCharm?
No, you can use whatever IDE you want for Python. I'm going to do everything in PyCharm. But yeah, if you like another one, have at it. Yep, thank you.